us find out the relation between the Laplace transform and the continuous time Fourier transform. So we know that x of omega is, that's a continuous time Fourier transform, integral minus infinity to infinity x of t e power minus j omega t dt. And whereas the Laplace transform, x of s is given as minus infinity to infinity x of t e power minus st dt. And here you know that s is sigma plus j omega. We are plotting the s values on the s plane, and this is the sigma axis and this is the j omega axis. So this is the s plane and this is the origin. And if you observe here, if you make the sigma equal to 0, then x of s will be nothing but your continuous time Fourier transform. That is, x of omega is x of s where sigma is 0. This indicates that in the s plane, if you observe the sigma equal to 0 means it indicates in this point, and this s equal to sigma plus j omega. So when you make sigma as 0, the s value will be j omega values. This is nothing but simply your j omega axis, that is, it is j omega axis in s plane. So when ROC of the Laplace transform or x of s includes j omega axis, then x of omega exists for such signal or such function, okay, such function x of t. Okay, if in the s plane, if we consider the ROC is, suppose this is the pole, if the ROC is right side of this pole, okay, if the ROC is like this, and this ROC covers the j omega axis. So x of omega, that is Fourier transform, exists for that signal. If the ROC doesn't include j omega axis, that is, if the pole is like this and this is j omega axis and this is sigma, if the ROC is right side of this pole like this, this ROC doesn't covers the j omega axis. So x of omega, that is Fourier transform, doesn't exist. Okay, so this is the relation between the Laplace transform and Fourier transform. That is relation between Laplace transform and Fourier transform, that is CTFT. That is, as we have seen that x of omega, the Fourier transform is nothing but x of s when sigma is 0. Okay, so based on this you can find the relation between the Laplace transform and the Fourier transform. Okay, so let us solve some basic problems. So starting with your impulse function, let us find out the Laplace transform of delta of t. The Laplace transform delta t, you know the expression, that is integral delta t e power minus st dt minus infinity to infinity, and you know that delta t is existing at t equal to 0. So 1 e power minus s into 0. Okay, and this is 1, and this exists for all values of s. That is, ROC is entire s plane. So ROC is entire s plane. This is a standard transform pair. That is, for Laplace transform of delta t is 1, and the ROC is entire s plane. Okay. Next, Laplace transform of u of t. Laplace transform of u of t, the same, substitute in the expression, that is u of t e power minus st dt integral minus infinity infinity. That is, you know that u of t is existing between 0 to infinity with a value of 1. So e power minus st dt. Okay. So this is, the value will be e power minus st by minus s. Substituting the limits, you will get the answer as 1 by s. 1 by s. So here the ROC is the real part of s greater than 0. So this exists for real part of s greater than 0. Then only the integration will converge. Okay. So this is sigma greater than 0. So the Laplace transform of u of t is 1 by s sigma greater than 0. Okay. Let us remember these expressions, the standard transform pairs. We will use these things while solving the problems using properties. Okay. Right. So with this basic property standard pairs, let us solve the some other things. That is, let us take a right-sided signal x of t e power minus at u of t. Okay, and where a is a positive value. Let us solve that. X of s is, you know, minus infinity infinity. X of t is e power minus at u of t e power minus st dt. Okay, so this is 0 to infinity. This is because u of t e power minus a t e power minus st dt. And let us rewrite this one as 0 to infinity e power minus s plus a into t dt. So this is minus 1 by s plus a e power minus s plus a into t. Let us substitute these limits. So you will get the answer as 1 by s plus a. So now here we have to find out for what values of s this exists. That is, what is ROC? So the ROC is, this expression should be valid for certain values of s. So if you observe this integral e power minus s plus a into t, this integration will convert when only the real part of s plus a is positive. Okay, when the real part of s plus a is positive. So if you solve this thing, that is, let me rewrite this one, e power minus sigma plus a plus j omega into t and dt. So e power minus sigma plus a into t and e power minus j omega t. This integration will converge when this sigma plus a is positive, that is the real part of s plus a is greater than 0. So this is the ROC. Okay, so the ROC is real part of s plus a greater than 0, that is sigma plus a greater than 0, sigma greater than minus a. So the Laplace transform of e power minus at u of t is 1 by s plus a for the values the ROC sigma greater than minus a. Okay, and this is the right sided signal e power minus at u of t, the Laplace transform is 1 by s plus a, the ROC is sigma greater than minus a. So in the j omega axis, sorry, in the s plane, if you take that, this is the minus a, this is the pole. Okay, so the ROC will be sigma greater than minus a, that is right side of the straight line. So here the ROC is a strip. Okay, so right side of this pole, that is minus a, and observe that this is the right sided signal, and you can make an observation that for this right sided signal the ROC is right side from that pole, and this ROC doesn't include poles. Okay, ROC doesn't include pole. Okay, and you have to make sure that you should not include this minus a in this ROC, right? So this is an important transform pair, e power minus at u of t, the transform is 1 by s plus a, ROC is sigma greater than minus a. Let us solve for the left sided signal. X of t is e power minus e power minus at u of t, u of minus t, the left side signal. For this one, let us solve. The x of s is minus infinity to infinity minus e power minus at u of minus t e power minus st dt. And because of this u of minus t, let me rewrite this. This is from minus infinity to 0. Okay, because of u of minus t, e power minus at e power minus st dt. Okay, and I will change the integration limits from negative time to the positive time. So integration 0 to infinity, this will be e power a plus s into t dt. Okay, and this will be minus 1 by s plus a e power a plus s into t, substitute the limits 0 to infinity. So here you have to make an observation that while substituting the infinity, you will get the sum as the you will get a value of infinity. Okay, but while substituting the 0, you won't get, you will get an value as 1 by s plus a, that is by substituting infinity you will get infinity, like let me write this, e power a plus s into infinity by s plus a, and minus minus plus, this will be e power a plus s into 0 by s plus a. So this will be infinity. and this will be 1 by s plus a. So to get a valid answer, to get a valid expression, you have to choose a proper sigma value for the convergence of this x of s. So for the existence of this one, we have to make sure that the real part of s plus a, should be negative. Okay, the real part of s plus a, this is the important term you have to consider. This value should be negative, real part of s plus a should be negative. Okay, that is sigma plus a should be negative. So sigma value should be less than minus a. So this is the ROC for the existence of x of s for the given signal minus e power minus at u of minus t. So your answer will be 1 by s plus a for, that is ROC, sigma less than minus a. Okay, so this is the Laplace transform for the left sided signal minus e power minus at u of minus t, that is 1 by s plus a, sigma less than minus a. So you can observe that for the right sided signal e power minus at u of t, the answer is 1 by s plus a, but the ROC is sigma greater than minus a. But here the ROC is, if you make it as minus a, the ROC is left side. This is sigma and this is j omega. Okay, so this is the left sided signal. The ROC is left side from that particular pole, minus a. Okay, minus a. So this is the observation you can make from a right sided signal and the left sided signal. From the for the right sided signal, the ROC will be right side of that pole. For the left sided signal, the ROC will be left side from this pole. Okay, so the difference is that the ROC for this signal e power minus at u of t and minus e power minus at u of minus t, right? So let us solve other questions, the combination of two signals, and let us find out x of s and find out the ROC. Find the Laplace transform of the given signal x of t e power minus 3t u of t, and observe this is a right sided signal e power minus 2t u of t. This is also a right sided signal. Okay, so as we know that you have some standard transform pair, e power minus at u of t transform is 1 by s plus a, sigma greater than minus a. So we use this transform pair. So for the x of s is Laplace transform of e power minus 3t u of t plus Laplace transform of e power minus 2t u of t, and let us use this formula. So here a is 3 and here a is 2, so 1 by s plus 3 plus 1 by s plus 2. So this is the Laplace transform for x of t, but you have to mention the ROC. Okay, mention ROC. So what will be the common ROC? For this one, the ROC is, this is the right sided signal and this is the right sided signal. The ROC is sigma greater than minus 3, and for this one ROC is sigma greater than minus 2. Okay, if both signals are considered, what will be the common ROC? Okay, so let us plot these poles on the S plane, and this is the S plane. sigma and j omega. The two poles are, one is -2 and -3. Okay. So one ROC is sigma greater than -3, like this. And another ROC is sigma greater than -2, that is this one. So if you observe, the common shaded part is sigma greater than -2. The common shaded part is this one, the common shaded part. Common ROC or common values. Yes. And these are the common values of S where the X of S exists. So the common ROC or entire ROC is sigma greater than -2. Okay, sigma greater than -2. So the final expression X of S is 1 by S plus 3 plus 1 by S plus 2 for the value sigma greater than -2. So this is the answer. Okay. So these two are right sided signals, and observe here, provided these two are right sided signals and the common ROC will be right side of the minimum pole. Okay. And this is the property of ROC. If you have the two right sided signals, the common ROC will be, that is sigma will be greater than sigma or else pole max. That is real part of S will be greater than sigma max, sigma minimum. Okay, minimum pole. Okay, here the minimum pole is -2. So right side of this minimum pole, you can consider several signals, several right sided signals. For that, common ROC will be the least pole from the, right side of the least pole. Okay, right. Let us see another one. X of t e power minus at u of t plus e power minus bt u of minus t. Let us solve this one and find Laplace transform and ROC. So X of S is, directly you can make this 1 by S plus A and minus of 1 by S plus B. Okay. Minus of 1 by S plus B. So what will be the ROC? And this is sigma greater than minus A. And for this one, this is sigma less than minus B. For the existence of this X of S, the ROC will be, if we consider that, let us take this is minus A and this is minus B, let it be. So one is right sided signal. Okay, that is from minus A, the ROC is like this, and from minus B, the ROC is left side. So the ROC is sigma in between minus A and minus B, and condition is that, provided that the magnitude of B should be less than magnitude of A, then only you will get an common ROC. Okay, suppose B is -2 and A is -3. Okay, you will get a common ROC like this, a strip. One is right sided and one is left sided. Okay, the common ROC is sigma in between -2 and -3, and this is the case 1. Suppose B is greater than A, that is B is 4 and A is 2. So B lies here. Okay, that is B is -4, -2. B lies here. This is A and this is B, and this is B and this is A. So B is left-sided signal. So the ROC will be like this, and the pole consisting A is the right-sided signal. So the ROC will be like this. So in this situation, there will be no common ROC. Okay, so we have to make sure that the magnitude of B should be less than magnitude of A. Then only common ROC exists. Okay. Right. So coming to the next one. So here let us see some properties. Okay. So based on few properties like time shifting, frequency shifting, scaling, and time differentiation property. Let us see some properties. We will solve those things. So one is about the linearity. So linearity property, ax1 of t plus bx2 of t. The Laplace transform will be a x1 of s plus b x2 of s. And the second, scaling property, x of at, the Laplace transform is 1 by mod a x of s by a. Third one, time shifting, x of t minus t naught, the Laplace transform is x of s multiplied with e power minus st naught. Okay, you can compare it with the Fourier transform also. There we have seen that for x of t minus t naught, the Fourier transform will be e power x of omega e power minus j omega t naught. Okay, so here we represent with s and here we represent with j omega. So you can find the similarities. Same x of t plus t naught, x of s e power s t naught. Okay, and this is the Fourier transform property. Coming to the frequency shift. So when you observe the frequency shift, that is s minus some shift like s minus a, observing some shift in frequency domain, here your x of t is multiplied with e power minus at. Okay, observing shift of a, s minus a, and you will observe, this will be positive here, this is positive. X of s minus a, its signal will be e power at x of t. The same if you observe s plus a, you will get x of t multiplied with e power minus at. Okay, and here a is some constant that observed the shift in the frequency domain. Okay, the another one, time differentiation. Okay, so differentiation in time domain, that is the derivative of d by dt of x of t. The Fourier transform of x of t derivative is s into x of s. Okay, and considering the initial conditions are 0. Okay, initial conditions at 0. Okay, and for nth time, that is nth derivative of x of t, simply s power n x of s. Okay, and the differentiation in s domain, differentiation in s domain. So this will be d by ds of x of s, and this is for minus t x of t. Okay, for the nth derivative in s domain is minus t power n x of t dn of x of s, nth derivative. Okay, and another one, convolution property. You know that in every case, that is in the Fourier transform, Laplace transform, or Z transform, anything, convolution in time domain results in multiplication in frequency domain. x1 of s multiplied with x2 of s. Another important property, initial value theorem and final value theorem. So in the initial value theorem, x of 0, the initial value you can get it as limit s tends to infinity s into x of s. The final value theorem, x of infinity, the final value can be obtained by limit t tends to infinity x of t, that is final value, is limit s tends to 0 s into x of s. Okay, so these are important properties we can use while solving some problems. Okay, right. Let us see how to solve a few problems using these properties. Let x of t is cos omega naught t u of t. So you can solve it using the Fourier transform, by using the traditional formula, x of s, x of t e power minus st dt minus infinity to infinity. Okay, you can use this formula, or else using property. Okay, let us solve by using property. By using property, I will break this cos omega naught t into exponential terms. So x of s is integral cos omega naught t u of t e power minus st dt minus infinity to infinity. So because of u of t, sorry, this is by using expression, so not by using property. Let us solve later by using property. This is by e power j omega naught t plus e power minus j omega naught t by 2. I will write integral 0 to infinity by removing u of t e power minus st dt, and this will be e power minus s minus j omega naught into t dt integral 0 to infinity plus 0 to infinity e power minus s plus j omega naught t. So if you solve these expressions like e power minus s minus j omega naught t by minus s minus j omega naught to infinity plus e power minus s plus j omega naught t by minus s plus j omega naught, so 0 to infinity. If you substitute these limits, you will get the x of s as s by s square plus omega naught square, and the ROC is real part greater than 0. Okay, the ROC is real part greater than 0. So the Laplace transform of cos omega naught t u of t is this one. Okay. So if you solve this by property, solving using Laplace transform property, okay, so I will consider is cos omega naught t, cos omega naught t u of t e power, I am writing this cos omega naught t and u of t as e power j omega naught t u of t plus e power minus j omega naught t u of t, like this. So I will take this one as the x of t. Okay, here I am using the frequency shifting property. Okay, that is e power at x of t, this will be x of s minus a, and same e power minus at x of t x of s plus a. So I am using these two properties, frequency shifting properties. Using the frequency shifting properties. Okay, so x of t is u of t. So what is x of omega? Sorry, x of s, 1 by s. So I will shift this 1 by s. So I am for this one e power j omega naught t u of t plus e power minus j omega naught t u of t. This will be 1 by 2 of s minus omega naught. I am taking common for the both terms. 1 by s minus omega naught plus 1 by s plus omega naught. So getting that s plus omega naught plus s minus omega naught by s square minus omega naught square. So you will get 2s by 2s square minus omega naught square. So this is s by s square minus omega naught square. So this is the sorry, here you have to mention j. So I forgot about j omega naught. So this will be plus omega naught square. So this is plus omega naught square. So this is the approach to solve the problems very quickly using the property. This is the frequency shifting property. Similarly, you can find out for the sine omega naught t u of t, sine omega naught t u of t. The same approach. So you break the sine omega t into e power j omega naught t plus e power minus j omega naught t by 2j multiplied with u of t. Okay, same approach. Apply the Laplace transform, frequency shifting property. You will get the answer as omega naught by s square plus omega naught square. Okay, so these are also the standard transform pairs. That is cos omega naught t u of t. The Laplace transform is s by s square plus omega naught square sigma greater than 0. Sin omega naught t u of t is the Laplace transform is omega naught by s square plus omega naught square. Okay, so I will give some few standard transform pairs. Similarly, e power minus at cos omega naught t u of t. How you can find out? Now here this is x of t. Okay, this is x of t and this is again e power minus at. Again frequency shifting property x of s plus a. Okay, so the transform for e power minus at cos omega naught t u of t is s plus a by s plus a whole square plus omega naught square. Okay, I am using this one. The same e power minus at sine omega naught t u of t. This is omega naught by s plus a square plus omega naught square, and here the both ROC is sigma greater than minus a. Okay, if the pole is minus a, so in the previous one the pole is 0. Okay, so sigma greater than 0 and here sigma greater than minus a. This makes a lot of difference, right? So let us go for another property. Laplace transform of u of t minus 2. U of t minus 2. Here the time shifting property. You know this one. That is u of t Fourier transform Laplace transform is 1 by s. I am using the time shifting. So u of t minus 2 is 1 by s multiplied with e power minus 2s. Okay, right. So let me discuss another problem. So if you want to apply a few more properties, you can go for the convolution or combination of different properties. So let us see that x of t is e power minus 2t, that is u of t minus u of t minus 5. Okay, so rewriting the expression e power minus 2t u of t minus e power minus 2t u of t minus 5. So by using the standard transform pair, you can see this s plus 2 and the ROC is sigma greater than minus 2. But here, to use the time shifting property, here you can observe the t minus 5. So here also you should have the t minus 5. So for making that e power minus 2 t minus 5, I am multiplying with e power minus 10. Okay, multiply this as, here I am making it as an e power minus 2t e power minus 10, sorry, plus 10. So multiply with e power minus 10. So now you can go for the time shifting property. Okay, and this is e power minus 10. So e power minus 5s 1 by s plus 2. Okay, so the ROC is sigma greater than minus 2. The time shifting property here also applied. So x of s is 1 by s plus 2 plus e power minus 5s plus 10 1 by s plus 2 and the ROC is sigma greater than minus 2.